Hi everyone. I'm sure you all know divisibility tests for numbers like 2 and 3, but what about numbers like 7 or 13 or 17? Do we have rules for those? Well, we actually have divisibility tests for any prime number. They're not as easy to implement as divisibility tests for say 2 and 3, but they're surprisingly not hard to derive and can still be pretty useful. Let's get to deriving. We'll start with divisibility by 7. Some of you might already know this one, but we're going to derive it instead of just memorize it. And then we'll use this derivation to generalize a way to make a divisibility test for any number. First, let's make an arbitrary number n with digits a sub 0, a sub 1, a sub 2, all the way up to a sub n. Now we can rewrite this number as the following. We can factor a 10 out of all the terms except the last term, which will give us this. Now this step might seem useless at first, but we'll now add 10 times x times a sub 0 and then subtract 10 times x times a sub 0, where x is just some arbitrary constant, which will be sort of important in the future. Effectively, all we've done here is just add 0, so the expression has the same value as before. We can rewrite the expression a bit, which will give us 10x plus 1 times a sub 0 at the end. Let's assume that 10x plus 1 is a multiple of 7. This would mean 10x plus 1 times a sub 0 is also a multiple of 7. From there, we know that in order for n to be a multiple of 7, the left term must also be a multiple of 7. Narrowing it down even further, we note that 10 is not a multiple of 7, which means that the expression inside parentheses must be a multiple of 7. We can rewrite this expression as the floor of n over 10 minus x times a sub 0. This must be divisible by 7 in order for n to be divisible by 7, which is our divisibility test. We just need to figure out what x is. We know that we assume 10x plus 1 must be a multiple of 7, and an example of when this is true is when x equals 2. So now we know that in order for n to be a multiple of 7, subtracting twice the last digit of n from the remaining digits must give a multiple of 7. You can test this for yourself with any number to verify that this works. So how do we generalize this formula to any prime number p? Well, we do the same process as before and get this expression. We assume 10x plus 1 is a multiple of p, like before, and we end up with the same outcome as before. In order for a number n to be a multiple of p, subtracting x times the last digit of n from the remaining digits must give a multiple of p. Here, x is a constant, where 10x plus 1 is a multiple of p. For example, when p is 13, we can have x be negative 4. In this case, the divisibility rule would be adding 4 times the last digit of n from the remaining digits. You can do this with any prime number above 5, solve for a certain value of x, and then reach your divisibility rule. So hopefully through these derivations you come to understand how divisibility rules work and how to derive some of your own. Thanks for watching.